Okay, so on this question, it says a superintendent of a school district says that about 22% of the students come from a single parent home. You are not sure. And so you conduct a study to test this claim. In your sample, 28.5714% of 77 students come from a single parent home. Test the superintendent's statement at a level of significance of alpha 0.05. Okay, so let's go to the notes. Unit 3 notes. This is page 2, hypothesis testing. It says, first off, do you have a percentage question or a mean average question? Well, this one is a percentage question, right? It's about 20. They're claiming 22% of the students come from a single parent home. It's a percent question. So for a percent question, you're supposed to use the online calculator z-test for a population proportion. So that's where we're going to go. That's their first question here. We should use a z-test for a population proportion. Next, we got to do the HO and the H1. How do those work? Well, it says here in the notes again, HO, get rid of my scribbles here. HO is always P equals or U, which is really mu, equals. So we're going to use P because it's a percentage question. And notice HO is always equals. And H1 is again going to be P. It's not going to be U. U is for, it's really mu, and it's for average questions, which this is not an average question. This is a percentage question. It's going to be greater, less, or not equal. And H1 is always strong evidence. We'll get to that in a minute. So H1 is greater, less, or not equal, and HO is equal. So let's go back here, as it says. So this is going to be P equals, and what does it equal? We'll get back to it. And this one's going to be P. It's going to be greater, less, or not equal, because this is H1. Okay, so which is which? Well, how do you know which one? You here again, we say H1 is greater, less, or not equal. How do you know? Well, it's greater if it says the word greater, bigger, faster, something like that. Less if it says smaller, tiny, or something like that. And then not equal if it says same, different, or just never says greater, less. That's our situation. See, ours is going to be, if you look back at the words here, it's going to be not equals. And how do I know that? Because it never says greater or less, right? As you read the words, let's read it again. Superintendent of a school district says that about 22% of the students come from a single parent home. You think it's more than that. Nope, doesn't say that. You think it's less than that. Nope, doesn't say that. It just says you're not sure. You're not sure. So it never says anywhere, whoops. It never says anywhere greater or less or bigger, faster, nothing like that. So that means it's not equal. You're testing whether it's not equal to what? Not equal to 22%. So it's going to be 0.22, and this is going to be 0.22. These, by the way, these are always the same. Same number always. So we're saying, okay, the HO, the first attorney, that's called the null. This is the null hypothesis. The null is the zero. It's a fancy math science word for zero. So this is the null hypothesis, and it's saying the proportion is equal to 22%, right? 22% of the students come from a single parent home. And the other attorney, H1, is saying, no. The proportion is not equal to 22%. So they're arguing. We're going to find out who has the evidence on their side. So again, HO is saying equal 22, H1 saying not equal to 22%. And the reason we didn't do greater or less is because they just never said, I'll just write it right here, never said greater or less in the words. You know, the words up there. It just never said greater or less. So that's how I know it's actually a not equal. So again, back to the notes. If it says same, different, or if it just never says greater or less, you use not equal. And that's us. That's exactly what we're doing. So we come back and go, okay, so it's a not equals. That's probably the trickiest part of this question, is that it indeed is a not equals question. Okay, so now it's time to get the test statistic and the p-value. How do we get those? Well, go back to the notes. It says step 3, identify. Yeah, so again, it's a percentage question. Go to the online calculator, hypothesis test for a proportion. Hypothesis test for a proportion. And we're going to have N, X, P0 in the radio button. So I'll just write that out for us. We're going to go hypothesis test for a proportion. And we're going to have N, X, P0, and the radio button. Okay, and so what is N always? You know, that's always the total number. X is the number we want. P0 always comes from H0. That's why it has a little zero, so I'll just put that in right now, 0.22. And the radio button, that always comes from H1, not equal. So we're going to choose not equal for the radio button. So those last two options, P0 and radio button, come from HO and H1. The number from HO, the symbol from H1. What's N and X? Well, N, 77. We surveyed 77 students. Okay, so I'll put that. In fact, going to need to move this over, give it a little more room here. We surveyed, move it over here. It's a total number. So that's going to be 77 students. And then what is X? X is, you know, again, the number we want. And how are we going to figure that out? Well, if you look at the notes, it says right here, X is the number asked for. This must be a whole number, not a decimal. If you're given a percentage like we are, like 23% of 80, then multiply 0.23 times 80, get your 18.4 and round it. So that's what we're going to need to do here. So we go, oh, okay. So I'm going to need to take this X, and it's the number we want. What do we want? Well, it says 28.5714% of 77 students come from a single parent home. So I'm going to need to take going to change it to a decimal, 0.285714 times 77, right? So we grab this right here and bring it right there. That's the number we want. So, and then you're going to hit the buttons on the calculator. So 285714, let's go to the calculator. 285714. So I'm going to go to the hypothesis test for a proportion. That's number 16. Click on number 16, hypothesis test for a proportion. And then to put in the N was 77. The P0 was, I can't remember. Let's go back here. P0 was 0.22. 0.22. So 0.22. And now we've got and then the X, remember we got to go back and get that. So what's the X again? It's right here. 285714 times 77. 285714 times 77. Well, to get that, I'm going to have to click on science. See the scientific calculator at the bottom? Click on that. I just clicked on scientific calculator. So 0.285714. Is that what it was? 285714. I can't remember. Yeah, 285714 times 77. So I'll go back here. 25714 times 77, enter. So 21.99999, to round that, that'll round to 22, won't it? Then choose the radio button, not equal. See how I'm choosing the radio buttons over here? Not equal. Oop, there we go, not equal. So you see what I did? I multiplied and I got 22. Let me go back here and show you that real quick. This came out 21.99999, so it's 22. That's what it said. It said round it to the nearest amount. So 22. So that means 22 out of the 77 students that we surveyed came from single parent homes. So, all right. And so back to the online calculator. So we put in everything, and now we're going to hit and did the radio button for not equal and hit calculate. So there it is. There's our Z and our P. Our P is 0. Our Z is 18.668. Let's go back to it. 18.668. Wait, no, that's different. Oh, did I do something wrong? Did I do 0.22 for the thing? Oh, look, yeah, I did. Oh, N, N's only 7. That should be 77. Let me try again. Calculate. There we go. Now I just showing you how easy it is to mess up. I'm of course joking. So now my N is correct, 77. There we go. Z is 1.39. The P is 1.639. Let's see if that's right. 1.39. Yeah. Z is 1.39. There's the P value. All right. So there's how we get the Z and the P. Now it's time to draw a conclusion. So we come on down and we're gonna say, okay, so our p-value, so this is where you go, okay, so what's your p-value? Our, change that up. So our p-value, which is 0.1640, and then our alpha level, what is our alpha level? Come up here, it'll tell you alpha at the top. Alpha is 0.05 right here, so alpha 0.05. I go down, I go, okay, 0.05. So which one of these is bigger? Well, that one's bigger, right? 16 is bigger than 5. So, okay, so the p-value is bigger. So what does that mean? Well, you come on down to our conclusion. We have two options here, and we are on the second one here, right? If the p-value is greater, we're not on this one, but right, if p-value is less than alpha, you do this, but that's not us. So cross this out. Our p-value is greater than the alpha. So what does that mean? When the p is not low, the null must not go. Means when the p-value is not low, the null must not go away. That is, fail to reject the null, and so we keep the null, weak evidence. So I'm going to come back up here, and I'm going to go, okay, so I'm going to write that saying just to be helpful. When P is low, it's a catchy saying, the null, H, which is HO, must go. So that's the rhyming saying that all stats students learn for hypothesis test. When the P is low, the null must go. But let me add a little bit to be clear. First off, go where? Go away is what we mean. And in our case, this p-value, notice, is greater. The p-value 16 is greater. So when the p is not, I'm just going to add not, because our p is not low. This is not low. The p is not low. It's greater. So when the p is not low, the HO, the null, must not go away, which means what? I'm going to fail to reject the HO. I'm going to keep the HO. So here we choose fail to reject the null. And it says, I'm going to keep the HO, and it says weak evidence, which we have right there. Evidence. So where's that? That's it. That's right in here, right? When the P is not low, means when the P is not low, it's greater. The null must not go away. That is, fail to reject the null. Instead, we keep HO, weak evidence. Keep HO weak. So there's the weak evidence, and I'm keeping HO. And what does that mean that I'm keeping HO? Well, whatever HO says. What does HO say? Let's go. We're keeping HO. So let's go back on up and say, what is this is what we believe. We believe HO. What does HO say? This is HO, right? HO. He's saying P is equal to, but he's saying P is equal to 0.22. So that's why we choose here, equal to. So our conclusion is that the percentage of students who come from a single parent home is equal to 0.22. That's our conclusion. Meaning, we decided that the evidence is weak. So is there some evidence? So let me give you a big picture now. We got all the words worked out. The big picture is we tested this. The superintendent said it's 22% of students come from single parent home. We did a little sample, 77 students. We got 28.5714%, which is not the same as 22, but it turns out it's pretty close, right? Because we know life has a randomness to it. We think that we just got, the reason it wasn't exactly 22 is just by random luck. Why do we think that? Well, because the p-value, remember what the p-value is, which we got right here? It's the probability of luck. P-value is the probability. Let me write that. That's going to be important in this course. P-value, which is 0.1640, is the probability of lucky sample. That we just got a lucky sample. The reason we didn't get exactly Yeah, so we'll say not exactly 22%, right? Because the superintendent said 22% come from single parent homes. We said, well, we did a sample at random, 77, we got more than that. We got 28%. Well, that was just a lucky sample. At least the chance of that being a lucky sample is 16%. That's pretty high. Anything higher than a 5% chance, we think is just too likely to have happened by luck. We only want to believe results that have a very low chance of luck. We think, because you might think, well, 16 is not very high. Well, yeah, it's not super high, but it's higher than 5%. We only want to believe a study if there's strong evidence with less than a 5% chance of luck. So this is way more than 5% chance luck. So we think, yeah, we probably just got a lucky sample. Probably really the superintendent's right, and 22% of the students do come from a single parent home, around 22%. And the reason we got 28% when we did our survey was just random luck. At least there's a 16% chance it was just random luck, and that's higher than 5. So when that p-value is high like that, when the p is not low, the HO must not go away. We keep the null. We keep the original statement made by the superintendent that the percentage probably really is equal to just 0.22 because the evidence is weak, meaning there's a high chance it was just lucky. And so we're keeping the null. And we believe that the percentage really is equal to 0.22 because there's a high chance it was just lucky. It was weak evidence. So weak evidence is when there's a high chance it was just lucky. If there's almost no chance, if it was less than 5, there's only like a 1% chance of luck. We call that strong evidence. But this is weak. There's a 16% chance that we just got lucky on that data. The reason it didn't come out exactly at 22. So we believe it really is 22. And we just got a lucky sample, unlucky, whatever you want to call it. And so there's our conclusion.